Okay. Section 5.4 is a lot like what we were doing yesterday with 5.3. The only difference is yesterday I gave you the formulas for cosine. Today we're talking about sine and tangent. And these are the only formulas that I'm going to give you. If you look on your formula sheet, we only have sine, cosine, and tangent. Because if I asked you anything about secant, cosecant, or cotangent, you could do these formulas and then just get the reciprocal of your answer to answer those parts. So on the formula sheet, we have these options. Just like cosine, you had a sum and a difference formula, we have that for all of these. So same process, just picking the right formula, plugging in, and then using your unit circle to evaluate. So let's look at some problems. Sine of negative 15 degrees. So I need two things that add or subtract to negative 15. Since it's a negative, I'm going to subtract. I'm going to do maybe 45 minus 60. You could do 30 minus 45. You could do negative 45 plus 30. Lots of options here.
I need that for a second.
So you just have to find two angles that add or subtract. Okay, so I need to look at the sine difference formula because I'm subtracting my two angles. So I'm using this formula. So it's sine of the first, cosine of the second. So that would be sine of 45, cosine of 60, minus cosine of the first, sine of the second. So minus cosine 45, sine of 60. Now we evaluate sine of 45, so use your hand trick, or look at a unit circle, sine of the y on your unit circle. So that would be radical 2 over 2. Cosine of 60, so 60 would be, cosine 60 would be 1/2, minus cosine of 45, so radical 2 over 2. Sine of 60 is radical 3 over 2. Multiply tops and bottoms just like yesterday, so radical 2 over 4 minus radical 6 over 4, or you could write that as radical 2 minus radical 6 all over 4. Okay. B, tangent of 13 pi over 12. We talked yesterday, sometimes it's a little bit harder with the radians, so let's just convert that to degrees. So I have to multiply by 180 over pi. So my pi's drop. 13 over 12 times 180 is 195 degrees. So I need two angles on my unit circle that add or subtract to 195. I'm going to use 135 plus 60. Okay, look at your formulas. We have tangent A plus B. So I am using this formula right here. My A is 135. My B is 60. And we are just plugging those in. So the formula says tangent A, tangent of 135, plus tangent B, so plus the tangent of 60, over 1 minus tangent A, tangent B. Okay, 135, that's quadrant 2. Reference angle 180 minus 135 is 45. In quadrant 2, sine is positive, so tangent's negative. Tangent of 45 is 1. Tangent of 60, use your hand trick, fold in your 60, square root of the top over square root of bottom, so radical 3 over radical 1 is radical 3. Over 1 minus tangent 135, we already said was negative 1. Tangent of 60 was radical 3. So it's negative 1 plus radical 3 over 1 plus radical 3. I want to take a second and talk about this. In the interest of time and being concise, I am actually going to allow you to leave your answer like this. However, normally I would tell you you can't leave a radical on the bottom. When we're dealing with the tangent formulas, a lot of times you will end with that radical in the denominator. If you wanted to get it off, you would have to multiply by the conjugate. So 1 minus radical 3. And you would have to FOIL the top, so that would give me a negative 1 plus radical 3 plus radical 3, so that's 2 radical 3, minus radical 9, so minus 3. On the bottom you get 1, minus radical 3 and plus radical 3 drop, minus radical 9, which is 3. And combine like terms, so negative 4 is 2 radical 3 over negative 2. If you divide everything by negative 2, you get 2 minus radical 3. I am going to allow you to leave your answer either in this form or this form. Because I am saying you don't necessarily have to get your radicals off the denominator, depending on what angles you use to add or subtract, you might get answers that look a little bit different. If you're not sure if your answer is equivalent, like if I'm giving you an odd problem and you're trying to check your answer in the back of the book, they will have the fully simplified answer. If you want to know if yours is equivalent, put it in the calculator, get a decimal. So I would plug this in my calculator, get a decimal. You could take the answer in the back of the book, plug it in and get a decimal and see if they're equivalent. Or you could just go to the point of simplifying every time. That is up to you. I'm just telling you how I will accept your answer on these. Okay, C. Okay, this time I gave you what looks like the right-hand side of the formula. I have tangent minus tangent over 1 plus tangent times tangent. I gave you this. So that means I have given you the tangent A minus B formula. This would be my A, and this would be my B. So this is tangent of 100 degrees minus 70 degrees. That's 30. Tangent 30, use your hand trick, radical 1 over radical 3, which is radical 3 over 3. I'm going to go ahead and do 3 more problems, just in case you're struggling. So if these 3 make perfect sense to you, you are welcome to skip the next little portion of my video, skip the next slide, and go on. Otherwise, continue watching here as I do some more practice problems. So if I give you sine of 75, 2 angles that add or subtract to 75 degrees. More than one correct answer. The simplest, what comes to my mind is 30 plus 45. You could also do like 135 minus 60. The angles you pick decide your formula. Because the 2 angles I picked have an addition, I am using the sine addition formula. So my A is the 30 and my B is the 45. So this would be sine of 30 cosine 45 plus
good to me.
Cosine 30. Sine 45. Okay, honey, I'll be downstairs in a minute. Let me finish this. Okay, sine of 30 is 1/2. Cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Sine 45 is radical 2 over 2. So radical 2 over 4 plus radical 6 over 4, or radical 2 plus radical 6 all over 4. Okay, E. 7 pi over 12. So again, change this into degrees. So we have to multiply. Times 180 over pi. Pi's drop. And we get 105 degrees. So I'm finding the tangent of 105 degrees. Two things that add or subtract to 105. You could do 60 plus 45. It's the first one that comes to my mind. You could also do like 135 minus 30. It's another option. Since on the last example I did a sum, I'm going to do the difference this time. So I have a subtraction here. That means I pick my tangent difference formula. So I'm picking the formula with the subtraction. Okay, because my formula has a subtraction, my A is just 135, my B is just 30, not negative 30. The negative is part of the formula, so my angle itself is positive. So that formula says tangent of the first minus tangent of the second over 1 plus tangent of the first, tangent of the second. Okay, 135, that's quadrant 2. Reference angle 180 minus 135 is 45. Quadrant 2, tangent's negative, tangent of 45 is 1. Tangent of 30 is radical 3 over 3. For 1 plus negative 1 times radical 3 over 3. So I have negative 1 minus radical 3 over 3 over 1 minus.
If I focus on
1 minus radical 3 over 3.
Now,
you cannot leave this in your answer. I'm allowing you to leave a radical on the bottom, but I'm not going to let you leave a fraction in a fraction. So the easiest way to just get rid of this is just take top and bottom times 3. If I distribute that, that gives me negative 3 minus radical 3 over 3 minus radical 3. I will accept this answer. If you chose, you can multiply by the conjugate and get the radical off the bottom as well. Last one. I have sine times cosine minus cosine times sine. So sine, cosine minus cosine, sine, that is this formula. So that's sine of A minus B. So my A is my 40, my B is 160. So this is asking for the sine of negative 120. We know if we have a negative angle, you could add 360 and get the coterminal. So 120 plus 360 is 240. That is quadrant 3. Reference angle 240 minus 180 is 60. Quadrant 3 sine is negative, and sine of 60 is radical 3 over 2. Okay. Last example. I want to simplify this. So I have the sine of 120 degrees plus pi, plus theta. So it's a plus, that means I'm going to my sum addition formula. My A is 120, my B is theta. So I have the sine of 120 degrees, cosine of theta, plus cosine of 120 degrees, sine of theta. 120 is quadrant 2. Reference angle 180 minus 120 is 60. In quadrant 2, remember all students, sine is positive. Sine of 60 is radical 3 over 2. Quadrant 2, cosine is negative. Cosine of 60 is 1/2. You could really probably leave it this way. You could multiply this. This would be like a radical 3 cosine theta over 2 minus 1 times sine would be sine theta over 2. Or you could even make one big fraction. I just wanted you to simplify it as much as you could. So really, I will accept any of these 3 for the final answer on that. Okay. One more. I'm going to change this to a minus. Let's do tangent of theta minus 3 pi. So that means I'm doing my tangent subtraction formula. So that's tangent of the first minus tangent of the second over 1 plus tangent of the first, tangent of the second. Okay, 3 pi, that's bigger than all the way around the circle, so if you subtract 2 pi from it, that's the same as pi, or 180 degrees, so it's like right here on the circle. If you're looking at your unit circle, that's the point -1, 0. Tangent's y over x, so tangent of 3 pi is just 0. So you have tangent theta over 1 plus 0, so that's just tangent theta. Okay. This is all I'm going to cover out of section 5.4. Again, in this chapter, with our circumstances, I am not covering everything. I'm just trying to hit the highlights so you have the big picture moving forward. This assignment, page 222 through 34, every other even. So it's like 9 problems again. Hopefully that's not taking you a tremendous amount of time. If you are spending a lot of time on this, then you're probably doing something